Beside me is the Baihetan hydropower station, built upon the Wujiang River, also known the Mother River of Guizhou Province. The Baihetan hydropower station navigation project opened to water traffic in 2021. It is the first of its kind in the world.
Imagine sailing effortlessly over towering mountains, not in a fantasy novel or a sci-fi film, but in real life. In China, this astonishing feat has become a reality, thanks to cutting-edge engineering and the country's massive investment in hydroelectric power. As the world's leader in hydropower production, generating an astounding 391 gigawatts of the global 130 gigawatts total, China has constructed some of the most powerful dams on Earth, including the record-breaking Three Gorges Dam and the colossal Baihetan Dam. But beyond sheer energy production, these marvels of infrastructure have given rise to an innovation that seems almost impossible: ships that appear to float over mountains. Today, we'll explore how China made sailing above the mountains possible. Let's get started. The need for a shiplift system. The idea of lifting a massive vessel over a towering obstacle may seem like a futuristic vision, something out of a science fiction novel or a grandiose engineering fantasy. However, this extraordinary idea has become a reality in China, where one of the world's most advanced shiplift systems allows vessels to traverse extreme elevation changes with remarkable ease. Located near the Baihetan Dam in Guizhou Province, this gigantic vertical shiplift eliminates the natural barriers imposed by rugged terrain and hydroelectric dams, offering an efficient and seamless solution for inland waterway transport. By integrating cutting-edge mechanical engineering with sustainable infrastructure, this marvel exemplifies China's dominance in hydropower and transportation innovation. So, what is this shiplift system? How does it work? And why does China need one? Unlike many countries with naturally navigable rivers, China faces severe elevation changes, mountainous terrain, and complex hydrology that make traditional water transport difficult. With the construction of massive hydroelectric dams like the Three Gorges Dam, these natural challenges have intensified. China's river systems, particularly the Yangtze River and its tributaries, are characterized by steep gorges and drastic altitude variations. Historically, these rivers were lifelines of trade, but their rapids, waterfalls, and cliffs made navigation nearly impossible. The Three Gorges Dam and Baihetan Dam, while vital for power generation and flood control, further raised water levels by hundreds of feet, creating a barrier for ships traveling upstream and downstream. Traditional lock systems, while useful in moderate elevation changes, cannot handle the extreme height differences imposed by these megadams, necessitating an entirely new approach. Waterways are among the most cost-effective and energy-efficient methods of transporting goods. The Yangtze River alone handles over 3 billion tons of cargo annually, making it China's busiest inland trade route. However, without a solution to bypass high-elevation dam reservoirs, the economic potential of these waterways would be severely limited. China is the world's largest producer of hydroelectric power, with an installed capacity of over 391 gigawatts, accounting for nearly 30% of global hydropower. However, the very dams that provide clean, renewable energy also fragment major rivers, cutting off navigation routes that once connected inland cities to the coast. China's long-term vision of economic and military strength is closely tied to its infrastructure expansion. The ability to quickly and efficiently move ships through its river networks enhances both commercial trade and military logistics. In a conflict scenario, rapid movement of naval and supply vessels through China's interior could be crucial for national defense. The development of shiplift systems also reinforces China's global leadership in infrastructure technology, setting a precedent for future megaprojects both domestically and internationally. As China continues to urbanize, its demand for efficient, high-capacity transport systems will only grow. The shiplift and aqueduct system is an investment in long-term sustainability, ensuring that water transport remains viable for future generations. By pioneering advanced solutions today, China is laying the groundwork for a fully integrated, high-tech waterway network that will solidify its dominance in global infrastructure for decades to come. So, what is this system and how will it work? Understanding the shiplift system. As China continues to develop its inland waterways to facilitate trade and economic growth, structures like the Baihetan shiplift are becoming essential. Unlike conventional locks, which gradually adjust water levels in a stepped process, this system directly lifts entire ships in a controlled, vertical motion, significantly reducing transit times. At full capacity, it can lift vessels up to 1,800 tons. This can fundamentally reshape river transport by allowing much larger ships to bypass the hydroelectric dam barrier with ease. The Baihetan shiplift was designed to solve a fundamental problem. Hydroelectric dams, while crucial for energy production, create impassable barriers for river transport. In regions like Guizhou province, where mountainous landscapes dominate, large dams are necessary to harness the power of rivers for electricity generation. However, these structures also disrupt trade and commerce by preventing the smooth movement of goods via waterways. The shiplift was constructed as a high-tech solution to re-establish connectivity, allowing vessels to bypass the dam's height in minutes rather than hours or days. Geographically, Guizhou province is known for its rugged topography and fast-flowing rivers, making it an ideal location for hydroelectric power generation, but a challenging environment for inland shipping. Without an advanced transportation system, the natural obstacles would force ships to unload cargo, transport goods over land, and reload onto another vessel. This is a time-consuming and expensive process. The Baihetan shiplift completely eliminates this logistical hurdle, ensuring that large cargo ships and passenger vessels can continue their journeys without interruption. When a vessel approaches the shiplift system, it first enters a specially designed canal that guides it toward the enormous vertical lifting structure. The process is highly automated and optimized for efficiency, allowing ships to align precisely before the lifting mechanism is engaged. From the moment a vessel enters the lift chamber, an astonishing transformation begins. Within minutes, it is smoothly lifted or lowered hundreds of feet, defying expectations and making river navigation more efficient than ever before. At the core of the Baihetan shiplift is its highly sophisticated lifting mechanism, which operates on the same fundamental principle as an elevator, but on a massive scale. Firstly, the shiplift employs high-tensile steel cables, capable of bearing immense loads without stretching or fraying. These cables are connected to enormous counterweights, which reduce the total energy required to move the ships. By balancing the load effectively, the system minimizes strain on the motors, improving both efficiency and longevity. The cables are then wound around massive drums, controlled by high-precision gearboxes on both sides of the structure. These components allow the synchronized lifting and lowering of vessels, ensuring that the motion is smooth and stable. Unlike dry dock lifts, the shiplift transports vessels in a sealed water-filled compartment, reducing stress on the hulls. The chamber itself is a colossal moving basin, large enough to accommodate ships of varying sizes. The lift is designed to use minimal energy by leveraging counterbalance principles and regenerative braking technology, similar to advanced elevator systems. Stability sensors ensure that the vessel remains perfectly level throughout the ascent and descent, preventing dangerous tilting or shifting. Altogether, this cutting-edge transport mechanism dramatically outperforms traditional step-lock systems, which require ships to wait through multiple stages of water level adjustment. One of the most striking advantages of the Baihetan shiplift is its incredible speed. While traditional locks can take hours to allow a ship to pass, this system completes the entire lifting process in just 10 minutes for a 500-ton vessel. Even at its maximum capacity of 1,800 tons, the system remains highly efficient, requiring only a slightly longer duration for larger ships. This time, efficiency has profound implications for trade and transportation. By eliminating lengthy delays, the ship lift significantly reduces overall shipping costs and improves the reliability of inland cargo transport. In a rapidly growing economy like China's, where industrial goods, agricultural products, and raw materials must be moved efficiently, such advancements make a substantial difference. The scale of the Baihetan ship lift is staggering. The excellence of the Baihetan ship lift. At full operation, the megastructure lifts ships to an elevation of 653 feet. This height is equivalent to a 66-story skyscraper, making it one of the tallest operational ship lifts in the world. To put the scale of China's ship lift system into perspective, the Great Pyramid of Giza, one of the tallest ancient structures ever built, stands at 4,076 feet. The Statue of Liberty, including its pedestal, reaches a height of 305 feet. Meanwhile, China's ship lift system at the Baihetan Dam in Guizhou province can raise vessels up to 653 feet. The engineering feat of lifting a fully loaded 500-ton ship to such an altitude is nothing short of extraordinary. Compared to other famous ship lifts, such as the Three Gorges Dam ship lift and the Strepi boat lift in Belgium, the Baihetan system is truly an engineering marvel. The economic implications of the Baihetan ship lift are vast. By ensuring uninterrupted river transport, the system enhances regional trade, reduces dependency on road and rail freight, and lowers fuel consumption. Since river transport is more cost-effective and environmentally friendly than truck or train alternatives, this innovation directly contributes to China's green energy and sustainability goals. From an environmental perspective, the ship lift offers several key advantages over traditional navigation solutions. For starters, unlike lock systems, which require substantial amounts of water to operate, the vertical lift system preserves water levels, making it a more sustainable choice. By encouraging river-based transport over fossil fuel-heavy road and rail options, the system helps lower overall greenhouse gas emissions. Since the lift does not require drastic water level changes, it helps maintain a stable aquatic environment, reducing stress on local fish populations and biodiversity. The Baihetan ship lift is more than just an engineering triumph. It represents the future of inland water transport, combining speed, efficiency, and sustainability into one revolutionary system. By overcoming the challenges posed by hydroelectric dams and natural elevation changes, this innovation proves that technology and infrastructure can work in harmony with nature. Projects like this set new benchmarks for global engineering. The ability to float ships over mountains is no longer a futuristic dream. It is a living reality. With its unmatched efficiency, massive scale, and environmental benefits, the Baihetan ship lift reflects the extent of human ingenuity and progress in today's time, ensuring that the waterways of tomorrow remain open, accessible, and sustainable for generations to come. So, how does this system operate? The working of the multiple lift mechanism. Unlike a single vertical lift mechanism, a multi-stage system, such as in the case of the Baihetan ship lift, comprises not one but three separate lifts, allowing ships to overcome staggering height differences that would otherwise be impossible to navigate. These lifts, working in unison, enable vessels to traverse extreme elevation changes with remarkable efficiency. The result is a highly optimized transport corridor, allowing seamless movement of cargo and passenger ships through complex hydroelectric dam structures. Conventional step-lock systems, which gradually adjust water levels in small increments, are too slow for modern transport demands. The multiple lift system solves this issue by providing a rapid, sequential lifting process that moves ships through hundreds of feet of elevation in record time. This multi-stage lift represents a significant leap forward in maritime engineering, proving that even the tallest dams can be conquered by human ingenuity. Unlike traditional ship lifts that move vessels in a single vertical motion, the multiple lift system employs a sequence of three colossal lifts, each serving a specific function in the process. This division optimizes efficiency while minimizing mechanical stress, ensuring smooth and reliable operations. The journey begins as a vessel enters the first lift chamber, where it is elevated a staggering 417 feet. This feat is comparable to the height of a 40-story skyscraper. At this stage, the ship is already at an elevation surpassing the Statue of Liberty, which stands at 305 feet. The vessel is then transferred to the second lift, which further raises it to a total height of 653 feet, which is equivalent to a 66-story building. This stage is crucial because it enables ships to surpass the highest dam levels while maintaining absolute stability. Upon reaching the peak, the ship is guided into the final stage, where it is lowered 154 feet to meet the downstream river levels. This step ensures that vessels can safely re-enter post-dam waters, completing the journey without requiring multiple manual interventions or complex lock sequences. This sequential lifting approach revolutionizes river transport, enabling ships to traverse previously impassable elevations with ease. Despite its complexity, the multiple lift system is designed for efficiency, ensuring a continuous and reliable flow of ships. Unlike traditional river navigation, where vessels move freely with the current, this system requires precise coordination to manage lift operations effectively. Unlike an open river, where vessels can sail at their own pace, the lift system requires a structured process. Ships enter the lifts one at a time, maintaining strict timing to maximize efficiency. To prevent bottlenecks, the lifts operate in parallel, allowing multiple ships to be processed at different stages simultaneously. While one ship is being lifted in the first chamber, another is ascending in the second, and a third is descending in the final stage. Traditional lock systems can take several hours to adjust water levels gradually, but the multiple lift system dramatically cuts down this time. The entire lifting process, from entry to exit, occurs in a fraction of the time, enabling more vessels to pass through each day. This high-capacity system ensures that even with increasing traffic, China's inland water transport network remains fast and reliable, reducing shipping delays and boosting economic activity. Constructing a multi-stage shiplift capable of handling hundreds of feet of elevation change presents numerous engineering challenges, from weight distribution to structural integrity. The sheer size and weight of the lifting mechanisms required extensive planning and innovative design solutions. For starters, each lift must support thousands of tons of weight without causing excessive stress on the structure. Engineers incorporated reinforced steel frameworks, counterbalance systems, and hydraulic dampers to ensure long-term durability and resistance to mechanical fatigue. Since the system consists of multiple lifts working simultaneously, precise synchronization is essential. Advanced computer-controlled automation ensures that the lifts move in perfect harmony, preventing misalignment or excessive strain on any individual lift. Lastly, given the enormous forces at play, fail-safe mechanisms are integrated into every stage. Multiple redundancy systems, backup power supplies, and real-time monitoring sensors help prevent mechanical failures, ensuring safe passage for all vessels. The multiple lift system is not just an engineering marvel. It also has far-reaching economic and environmental benefits. For starters, by enabling faster and more reliable transport, the system reduces costs for shipping companies and businesses, boosting trade efficiency across China's inland waterways. Also, inland shipping is far more fuel efficient than trucking or rail transport. By making river transport more accessible, the system lowers fossil fuel consumption and reduces carbon emissions. Moreover, unlike large-scale lock systems that involve continuous water level adjustments, the multiple lift system operates without excessive water displacement, preserving local aquatic habitats. With its ability to seamlessly transport massive vessels over staggering elevations, the multiple lift system is not just a technological breakthrough. It is a revolution in waterway transport, ensuring that China's rivers remain integrated, efficient, and primed for the future. Now, let's take a look at one of the most important components of this system: the aqueduct system. In the heart of China's mountainous landscapes, where steep elevations and rugged terrain make traditional river navigation nearly impossible, engineers have created an aqueduct system designed to bridge the gaps between massive shiplifts. Unlike conventional locks, which gradually adjust water levels to accommodate elevation changes, this system required an entirely new approach, an artificial waterway cutting through mountains, seamlessly linking the multiple lift stages into a single, continuous transit corridor. The aqueduct system is a key component of China's massive inland water transport modernization efforts, ensuring that ships can navigate high-altitude reservoirs and hydroelectric dams without delays. By bypassing natural obstacles that would otherwise render river navigation impossible, this 1.4-mile-long engineered waterway allows for a smooth, uninterrupted flow of vessels between shiplifts, effectively eliminating what would otherwise be insurmountable geographical barriers. Unlike traditional river navigation, where locks are sufficient to manage water level differences, the dramatic elevation shifts in China's mountainous regions made this approach unfeasible. The multiple lift system allows ships to ascend and descend extreme heights. But between these lifts, a stable and navigable passage was necessary. Conventional lock systems depend on incremental water level adjustments, but in areas where elevation changes are hundreds of feet over short distances, the sheer number of locks required would have been impractical and time-consuming. Instead of relying on natural riverbeds, which are fragmented by mountains and steep inclines, engineers conceived a controlled, artificial aqueduct, an uninterrupted channel that would allow vessels to move freely between lift systems. This aqueduct ensures that ships do not have to rely on inefficient, stop-and-go navigation. It essentially transforms disconnected reservoirs into a single, cohesive water route. The result is a continuous, navigable waterway that bypasses the geographic constraints of the region, allowing for seamless ship movement over extreme altitudes. Constructing a man-made river through mountainous terrain is no small feat. Engineers had to overcome immense geological and logistical challenges, ensuring that the aqueduct could withstand environmental pressures, support heavy shipping traffic, and maintain a steady flow of water. For starters, unlike natural river channels, which are shaped over millions of years, this 1.4-mile aqueduct had to be excavated with absolute precision. Engineers used advanced tunnel boring machines to carve out sections of the aqueduct through solid rock, creating a seamless passage without disrupting surrounding landscapes. The excavation process also required the creation of reinforced embankments, preventing landslides or collapses that could obstruct the waterway. One of the biggest challenges was maintaining a consistent water level throughout the aqueduct, ensuring that ships could travel safely without turbulence or excessive current shifts. Hydraulic control systems were integrated to regulate water velocity and depth, preventing bottlenecks or excessive water loss. Reinforced concrete channeling was used to minimize erosion, maintaining structural integrity over time. Moreover, because this aqueduct connects two of the world's largest shiplift systems, the transition had to be flawlessly smooth. Precision docking mechanisms allow ships to exit lifts and enter the aqueduct without disruptions. Adaptive water level adjustments ensure that ships experience minimal height differences, preventing sudden drops or surges that could destabilize vessels. These advanced engineering solutions allowed for the construction of an aqueduct that is not only functional but also resilient, efficient, and capable of handling continuous shipping traffic. China has long been a leader in tunnel construction and large-scale infrastructure projects, and the aqueduct system stands as one of its most impressive accomplishments. The country's expertise in mega-projects, from the world's longest high-speed rail tunnels to underground flood control networks, played a crucial role in the development of this engineering marvel. After all, China has successfully built some of the most complex underground transport systems in the world, including high-speed rail tunnels and deep-sea infrastructure projects. This expertise directly translated into the design and execution of the aqueduct. Unlike traditional aqueducts, which were designed solely for water transport, this system was built to work in tandem with shiplifts, hydroelectric power stations, and high-altitude reservoirs. The ability to synchronize multiple complex structures reflects China's mastery of large-scale engineering. As global shipping demand increases, and nations seek more sustainable transport alternatives, the ability to construct artificial waterways through challenging terrain will become an increasingly valuable skill. Similar aqueduct systems could be deployed in other countries facing difficult river navigation due to mountainous terrain. Unlike large-scale dam projects, which can have negative ecological impacts, aqueduct systems can be engineered with minimal disruption to natural habitats, offering a more environmentally friendly approach. Moreover, the successful execution of this project proves that no terrain is too extreme for human ingenuity. Future projects could take this concept even further, potentially integrating aqueducts into other high-altitude transport networks, such as rail and road infrastructure. It's not just about the shiplift and aqueducts. China is moving ahead in all areas one can imagine, and it matters to everyone. China is racing to the top. In the race for global dominance, China is setting a pace that few can match. From towering hydroelectric dams and futuristic high-speed rail networks to record-breaking shiplifts and artificial aqueducts, China's rapid advancements in infrastructure are not just reshaping its own landscape, but also redefining the limits of modern engineering. The scale, speed, and ambition behind these projects signal a deeper objective, positioning China as the world's leading superpower. Infrastructure is more than just a tool for economic growth. It is a statement of technological supremacy, national strength, and geopolitical influence. Innovations like the multiple shiplift system, artificial aqueducts, and the Three Gorges Dam are only some of the many examples of how China is rapidly outpacing the world in mega-project development, proving that whoever controls infrastructure controls the future. China has established itself as the undisputed global leader in infrastructure development, consistently delivering record-breaking projects that push the boundaries of human ingenuity. For context, the Three Gorges Dam is the largest hydroelectric project in the world and generates an astounding 22.5 gigawatts of electricity, making it one of the most powerful energy hubs on the planet. The Baihetan Dam, the world's second-largest hydroelectric station, is also present in China and boasts an installed capacity of 16 gigawatts, enough to power entire megacities. Similarly, the south-to-north water diversion project, another engineering marvel, redirects water from the Yangtze River to the arid north, supplying over 53 billion cubic meters of water annually. This was once thought impossible. But that's not all. China has transformed rail transport on an unprecedented scale, building the largest and fastest high-speed rail network in human history. Spanning over 42,000 kilometers, or 26,000 miles, this vast system connects more than 80% of the country's major cities, making long-distance travel faster, safer, and more efficient than ever before. Trains routinely exceed 350 kilometers per hour or 217 miles per hour, cutting cross-country travel times from days to mere hours. The introduction of magnetic levitation, or maglev trains, which can reach staggering speeds of 600 kilometers per hour or 373 miles per hour, has pushed the boundaries of ground transportation, making them the fastest land-based vehicles on Earth. A shining example of this innovation is the Beijing-Shanghai High-Speed Railway, a vital corridor that transports over 100 million passengers annually, showcasing China's ability to combine speed, efficiency, and mass transport on an unparalleled scale. China has also established itself as the global leader in bridge engineering, constructing more record-breaking bridges than any other nation. These awe-inspiring structures not only showcase China's mastery of civil engineering, but also play a crucial role in enhancing connectivity across vast and challenging terrains. The Hong Kong-Zhuhai-Macau Bridge, stretching an astonishing 55 kilometers or 34 miles, stands as the longest sea-crossing bridge on Earth, dramatically reducing travel time between three of China's most important economic hubs. Meanwhile, the Danyang-Kunshan Grand Bridge, extending 164.8 kilometers or 102.4 miles, holds the title of the longest bridge in the world, demonstrating China's ability to overcome geographical limitations with cutting-edge engineering. Adding to this list of marvels, the Baihetan Bridge rises 565 meters, or 1,854 feet, above the valley floor, making it the highest bridge in the world, and a testament to China's capability to construct infrastructure at extreme altitudes. China is not just expanding its infrastructure at an unprecedented scale, it is making it smarter. By integrating artificial intelligence and cutting-edge technology, the country is revolutionizing urban development and transportation, making its cities more efficient, responsive, and sustainable. 5G-powered smart highways, equipped with AI-controlled traffic systems and dedicated lanes for autonomous vehicles, are redefining road transport, ensuring smoother traffic flow and reducing congestion. Meanwhile, AI-managed urban planning allows cities to dynamically optimize traffic patterns, waste management, and power distribution, significantly improving energy efficiency and sustainability. Leading the charge are Shenzhen and Hangzhou, two of China's most advanced smart cities, where facial recognition, real-time data tracking, and AI-powered governance enhance public services, improve security, and streamline city operations. These innovations are not just modernizing China's infrastructure, but also setting a global benchmark for the future of intelligent urban living. China's infrastructure ambitions extend far beyond its borders, with the Belt and Road Initiative, or BRI, standing as the most ambitious global development project in human history. Spanning over 140 countries, the BRI is reshaping international trade by constructing a vast network of railways, highways, ports, and digital infrastructure that link China to Europe, Africa, and Southeast Asia. Massive railway projects now connect Chinese industrial hubs to European markets, drastically reducing transit times and dependence on traditional maritime shipping routes. At the same time, state-of-the-art seaports in strategic locations such as Gwadar in Pakistan, Hambantota in Sri Lanka, and Piraeus in Greece are expanding China's influence over global trade. Beyond transportation, China's strategic investments in power plants, telecommunications, and digital infrastructure across Asia, Africa, and Latin America are strengthening its economic foothold and securing long-term dominance in key global markets. The BRI is a blueprint for China's emergence as an economic superpower. So, how come this matters to everyone else? History has repeatedly shown that global superpowers are built on infrastructure, from the Roman Empire's vast road networks to America's interstate highway system. Nations that dominate transport, energy, and urban development become the centers of global power. China understands this better than any other country today. A country's ability to move goods and people efficiently defines its economic strength. With the fastest trains, most advanced highways, and largest shipping networks, China is securing its position as the world's central trade hub. By leading the world in hydropower, renewable energy, and nuclear advancements, China is ensuring self-sufficiency in energy and reducing reliance on fossil fuels while exporting energy solutions worldwide. Through the Belt and Road Initiative, China is rewriting the global economic map, making over 140 nations dependent on its infrastructure investments, a level of influence no other nation has achieved in modern history. Moreover, advanced roads, rail networks, and maritime routes not only boost trade, but also enhance military mobility, giving China an unmatched advantage in global strategic positioning. While Western nations struggle with aging infrastructure and political stagnation, China is forging ahead with a vision of the future. The sheer scale of its projects, the speed at which they are executed, and its technological superiority suggest one undeniable truth. China is not just competing with other superpowers, it is outpacing them. By 2035, China aims to have a fully integrated AI-powered transport and energy network, making it the most advanced infrastructure system in the world. By 2050, projections suggest that China's economic and geopolitical dominance will surpass that of the United States, fueled by its unmatched infrastructure expansion. China's Mars and Moon colonization programs will make it the leader in space infrastructure. The message is clear. Whoever builds the future controls the future. And right now, China is building faster, bigger and smarter than anyone else. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.